Welcome back. In the past few lectures, we successfully set our Databricks free edition, explored the unified workspace, and securely uploaded our raw data into Unity catalog volumes. We have the car, which is our serverless compute cluster. We have the keys, which is our notebook interface. We even have the fuel, which is our raw data. Now it is finally time to start the engine. In this lecture, we are going to run our very first piece of PySpark code. But we are not just going to type commands blindly. We are going to answer the most fundamental questions in distributed computing. Who is actually running the code? When you write a normal Python script on your laptop, your local CPU handles everything. It is simple, but in Databricks, you are interacting with a massive and distributed cluster. There is a sophisticated architectural handshake happening behind the scenes. In this lecture, we will demystify the SparkSession, which acts as the master gateway, and we will explore the driver and worker model. So let's start the engine. Alright, so let me start by deleting the previous cells. I just want to start on a clean slate. So let me delete that and hit that confirm button. Let me also delete this cell. And lastly, this one. All right, so in the first cell, I just want to check the Spark environment. And I just want to type Spark just like that. Now I want to switch on my serverless environment by simply selecting, the serverless cluster. All right, so this is running now. As you can see, it has turned green. Let me Shift Enter to run. Now, take a look at the output right beneath the cell. You will see a text output that looks something like this: PySpark.sql.connect.session.SparkSession at the very long alphanumeric characters that follow. Now, what exactly is this code doing? By simply typing the word Spark, you are calling the pre-configured object that Databricks automatically injects into your notebook. Running it prints out its memory address and connection type. Think of this as a quick health check to prove your notebook is successfully communicating with the serverless cluster. This object is your SparkSession. You can think of it as the master control panel for your entire cluster. It serves as the single and unified gateway through which all your Python code communicates with the underlying Spark engine. A quick piece of history for you. In the early days of Spark version 1, the architecture was quite fragmented. You had to manage a Spark context for core operations, a separate SQL context for data frames, and yet another Hive context for databases. Fortunately, starting in Spark version 2, Databricks consolidated all of these distinct contexts into the elegant and unified SparkSession we use today. The Spark object you have just printed operates as a singleton. Databricks provides a tremendous convenience here by automatically provisioning a SparkSession in the background and seamlessly injecting this variable into every active notebook. However, as a professional data engineer, relying on variables injected automatically is not best practice. You want to write portable code. You want a script that runs just as flawlessly in a Databricks notebook as it does locally on your laptop inside Visual Studio Code. To achieve that portability, we must manually instantiate the session using the builder pattern. So in your new cell, I want you to type this code. I'm going to copy and paste into the cell and then Shift Enter to run. Now let's look exactly what this code is doing behind the scene. It does not crash. The builder command initiates the configuration process. The app name function gives your application a specific name so you can easily track it later in the Spark monitoring user interface. The get or create function is the brilliantly smart part. When it runs, it looks around the environment and asks if there is already a Spark engine running. In Databricks, it says yes, it sees the serverless cluster. It ignores your setup instructions and safely returns the existing connection. So on your laptop, it says no because it does not see one. It then follows your instructions, builds a local mini cluster named My First Spark App, and returns a fresh connection. This exact block of code ensures your scripts can run literally anywhere. Now that we have our session connected, let us verify it actually works with a simple hello world query. This will also give us our first glimpse under the hood. So in your new cell, I would like you to type the following code. And then when you're done, Shift Enter to run. All right, so the Spark SQL command allows you to pass a standard SQL query as a string directly to the Spark engine. In this case, we are asking for the version. The show command is the action that tells Spark to print the result onto the screen as a text table. The truncate equals false argument is a handy formatting trick. It ensures that if the result is a really long string of text, Spark will not cut it off with an ellipsis. Now let's analyze the output. Take a look at the output table at the bottom. It successfully returned the current engine version. In my case, it shows version 4.1.0, followed by a massive string of zeros because we turned truncation off. Spark printed out that entire long string instead of cutting those zeros off and hiding them. But the version string is not the only interesting part. Look just above the table. Notice that the notebook cell took about 28 seconds to run. Now, if you expand the little drop down that says performance right here, you will see a line item detailing the underlying execution. Started at shows the exact timestamp. Duration shows how long the specific Spark job took. This is often just a fraction of a second, even if the notebook cell itself took 28 seconds to fully wake up and render. Task will show 1 out of 1 completed. All right, so that 1 out of 1 is visual proof of the driver and worker architecture in action. First, we have the driver, which is the brain. When you pressed Shift and Enter, your notebook sent this SQL command to the driver machine. The driver analyzed the request and created an execution plan. Second, we have the worker, which is the muscle. The driver then took that plan, created exactly one task, and assigned it to a worker machine in your cluster. Worker machines are also called executors. Finally, we have the result. The worker physically executed the function and handed the answer back to the driver, which then printed it on your screen. You might hear older engineers call this the master and slave architecture. The modern and correct terminology you should use in interviews is the driver and worker model, or the driver and executor model. So let us run one more quick example so you can see the workers handle multiple tasks simultaneously. So in a new cell, I'd like you to run the following and Shift Enter to run. Now take a look at the result. It ran in just a fraction of a second and correctly returned the count of 10. But more importantly, if you open the performance drop down for this cell, let's see what's going inside here. You will see it says 13 out of 13 tasks completed. The driver created the plan, divided the numbers into 13 buckets, and successfully distributed the counting tasks across multiple worker nodes simultaneously. Now, even for a tiny hello world command, That full and beautiful coordination engine kicked in. That split-second task duration you see in the performance drop-down is the network overhead of the driver talking to the worker. While doing a full cluster handshake might seem like overkill for printing a simple string, this exact same architecture is what allows Spark to seamlessly scale to process petabytes of data across thousands of machines. So we have the engine running and we understand the physical architecture, but Databricks has one more massive trick up its sleeve. Because we are using the SparkSession, we are not limited to just Python. We can actually mix Python and SQL together, seamlessly passing data back and forth between them. In the next lecture, we are going to explore the magic of polyglot programming, and I will see you there.